Hello and welcome back to Friday Minis. Now, ladies and gentlemen, imagine a world in which you can just use one standard cable. It's capable of carrying tons of data, it's capable of carrying a good amount of power for you to charge your devices. And what's cool is that with that one cable, whatever device you connect to whatever charger, they'll talk among themselves and figure out the best rate of charging. No more having quick chargers from one brand that don't work on a different brand. No more having to deal with chargers that don't put out enough power so your devices never charge. Imagine a world where all of that is behind us. This, ladies and gentlemen, is the world promised to us by USB-C. That's right, if you own a fairly modern device, if you own a MacBook, whatever, you are already using USB-C to charge your device. And that's really cool because at least on paper, they're able to, do the whole negotiation thing, right? So your device is able to talk to the charger and be like, hey, I like to draw a certain amount of voltage, a certain amount of amps, and they'll talk it out. And then, your device will be able to get the best amount of current for it to charge at its highest possible speed. And that's great, that's strangely utopian. And that's also not really how it works. Well, at least if you have USB-C to USB-C, a compatible charger, and a compatible device, then that's what happens in theory. But things start to get a little bit weird once you step beyond these ideal conditions. You see, what's very common nowadays to have on chargers are still USB-A ports. That is the same kind of USB port you have on your computer, right? The kind you plug your flash drive into. Of course, we want to charge our USB-C devices with those, right? So what we do is, we grab a cable that has USB-A on one end, USB-C on the other, and we just charge, right? That's fine. Except not quite. Because you see, if you take a closer look at the USB-C ports versus the USB-A ports, you will see that USB-C has a far greater number of pins. These pins are of course what USB-C uses to carry a lot more data. But also another important thing. The channel used by USB-C devices to communicate and to negotiate for, charge levels and things like that, that's on a pin that's not present on USB-A. And what that means, of course, is that, if you have a USB-A to C cable, the USB-C device is not able to do any negotiation with what it's plugged into. Luckily, the specifications give an alternative way of specifying current draw, and to understand this, we have to delve inside of a USB-C cable. While typically, the communication channel pin is used for negotiation, it could simply be connected to power through a resistor. The device can measure the current flow on that pin and use that to determine how much current can be drawn. If this was a cable and not a charger, it would of course not be able to tell the capabilities of the charger it was connected to. Hence, according to the specifications, it should claim the lowest possible charging capability by using a resistor at 56 kiloohms. This protects the charger. Of course, the problem here is that these specifications aren't being followed in some situations. If a manufacturer places a 10 kiloohm resistor instead, as is the case with some of the cables out there, the device will happily draw 3 amps of current, even if it was connected to a charger that didn't support that. This of course is bad, and there have been reports of one or both devices being fried, just because a wrong resistor is being used. Now, the reason why I bring this up now is because, recently I've laid my hands on this, a Nintendo Switch. Yeah, surprise! I've gotten myself a games console. It's shared, but you get the idea. There is something very interesting about how the Switch charges, because as it turns out, neither the charger nor the Switch itself is actually properly USB-C compliant, which is a pain to say the least. And there have been people frying their Nintendo Switches by using a USB-A to C cable and just plugging it into the USB port at the bottom. As it turns out, if the Nintendo Switch gets to overdraw, from the charger, it will, and something will fry. So that's not great, because you can break the Nintendo Switch doing that, and I'm absolutely terrified by the idea. Anyway, The real reason why I'm doing this video is to just bring this problem to your attention. All because it fits doesn't mean it, will work properly, and that's the unfortunate truth about, how USB-C is doing right now. Obviously, you won't have this problem if you use the official charger, if you use the official cable, official everything, because of course they're tested to work together. But, you don't always get to do that, so that's something worth noting. Anyway, I think that's enough rambling for an episode. Remember, if you're buying a USB-A to C cable, try to look for some kind of official certification if you want to be sure that it will work perfectly. I don't think there are many cables with that certification though, so yeah, your mileage may vary. Anyway, that's it. Thank you very much for watching this episode of Friday Minis. I hope you found it useful. But yeah, until next time, you're watching 0612 TV with NERDfirst.net. Thank you very much for watching. If you like my work and are feeling generous, you can shoot me a one-time donation on PayPal or sign up for a recurring one on Patreon. Of course, you can simply like, comment, and subscribe. You know the deal. For more videos, links to my channel and a related playlist are on screen. Thank you for your support.